units for mass, length, time, and force. Since we are considering thermodynamics properties from a microscopic perspective, we are dealing with quantities that can either directly or indirectly be measured and counted. Therefore, the matter of units become an important consideration. In the remaining section of this chapter, we will define certain thermodynamic properties and the basic units because the relation between force and mass is often difficult for a student to understand. It is considered in this section in some details. Force, mass, length, and time are related by Newton's second law of motion. Force, mass, length, and time are related by Newton's second law of motion, which states that the force acting on a body is proportional to the product of mass and the acceleration in direction of the force, as we know from dynamic and static also. The concept of time is well established. The basic unit of time is the second. So we have the basic unit. Basic unit of time is the second, which in the past was defined in terms of the solar day, the time interval for one complete revolution of the Earth relative to the Sun. Since this period varies with the season of the year. An average value over 1 year period is called the mean solar day, and the mean solar second is the mean solar second is of the mean solar day. The Earth's rotation is sometimes measured relative to a fixed star, in which case the period is called a sidereal day. For a period of time less than 1 second, the profile for period of time less than 1 second, we have milli, micro, nano, and pico. Milli, micro, nano, and pico. we have for a period of time greater than 1 and much greater will be shown with kilo as mega, giga, which also can use with other units, for example for length, and mass, pressure, or tera. The concept of length is also well established. The basic unit of length is the meter. For many years, the accepted standard was the International Prototype Meter, the distance between two marks on a platinum-iridium bar under certain prescribed conditions. This bar is maintained at the International Bureau of Weight and Museum in Mieres in Severs, France in 1916. The fundamental unit of mass is the kilogram. Unit of mass. As adopted by the first CGPM in 1889. And this it is the mass of a certain platinum-iridium cylinder maintained under prescribed conditions at the International Bureau of Weight and Measures. A related unit that is used frequently in thermodynamics is the mole. Related unit in thermodynamics is mole, defined as an amount of substance containing as many elementary entities as there are atoms in, for example, kilogram of carbon. These elementary entities must be specified. They may be atoms, molecules, electrons, or other particle or specific groups. For example, 1 mole of diatomic oxygen having a molecular mass of 32 has a mass of 32,000 kg. Anyway, the system of units in use presently throughout most of the world in the metric international system. We have two standard systems. SI system international metric, international system. Commonly referred to as SI units. In this system, the second, minute, and kilogram are the basic. Second, and kilogram. As just defined, a unit of force is defined directly from the Newton's second law, which is F ma. The British or US customary units British or US customary in the British we have different units for length and kilograms, but the same in the for time. The traditional system of unit used in the United States is the English engineering system. In this system, the unit of time is second, which was discussed earlier. The basic unit of length is foot, which at present is defined in terms of the meter as 1 foot. And 1 Newton is 1 kilogram. The unit of mass in the system is the pound mass, as shown here. Pound mass. We have also pound force for the 1 pound mass. Equals to a related unit in the pound mole. And we have also a unit for force, which is pound force. Pound force, which 1 pound force equals to the pound mass multiplied to the fourth or second square, which is necessary factor for the purpose of unit conversion and consistency. Anyway, we will encounter with the units frequently in this chapter. The next discussion in this chapter is energy.